Have you ever seen a shooting star? Did you make a wish? Or maybe you observed a large meteor shower? Every day, small rocks from space collide with our planet. Fortunately, most of these pieces are tiny and burn up harmlessly in our atmosphere. When you see these streaks of light in the night sky, it's the burning of those tiny rocks that you're witnessing. Even a rock the size of a grain of sand can create a mesmerizing trail of light. But what if the pieces weren't so small? If a large rock collided with our planet, would it make it through the atmosphere without burning up as a harmless streak of light? And if so, could this spell danger for living things on the surface? Well, the dinosaurs living on Earth 66 million years ago could answer this one. And the answer is a definite yes. Large rocks that cross Earth's path can do catastrophic damage and even drive entire species to extinction. Which brings up a rather terrifying question. Could a large space rock impact Earth in the future, spelling doom for humans? Well, we can't rule out the possibility. But the good news is that we now know more about this rogue space debris than ever before, and space agencies around the world have already developed strategies to defend our planet against such collisions, should it ever become necessary in the future. Today, we'll take a look at the debris floating around out there in our solar system, like asteroids, meteoroids, and comets, and what type of destruction they are capable of when they impact larger bodies like planets and moons. And most importantly, we'll see what we can do as a species to protect ourselves from these sometimes violent collisions. Solar system debris includes asteroids, meteoroids, and comets. But why are these objects called debris? Doesn't debris mean trash? Well, one definition of debris is scattered pieces of waste or remains. And this definition fits space debris because asteroids, meteoroids, and comets are the leftover scattered building blocks of our solar system. Over 4 billion years ago, when the planets were forming, not all of the material in the solar system was incorporated into planets or moons. Some fragments remained in space, too small to become planets, but still orbiting the sun. These remnants continue to drift through the solar system today. Whether they are rocky asteroids from the asteroid belt, icy comets from the distant Kuiper belt, or small meteoroids scattered throughout space, they all represent the debris of our solar system's formation, offering clues about its early history. So how do these three categories differ from each other? Looking at these three examples, what differences do you notice that could set these types of debris apart? Pause the video for a moment and record some observations in your notes. What observations did you make about the asteroid? Did you observe that it looked like a rock? That's exactly what they are, large space rocks. But just how big? Well, the smallest asteroids are around a meter across, but larger asteroids can be hundreds of miles across. Do you remember learning about the dwarf planet Ceres in a previous lesson? Until being classified as a dwarf planet in 2006, Ceres was considered to be the largest asteroid in the solar system with a diameter of nearly 600 miles. Ceres is the only dwarf planet in the asteroid belt, a region full of rocks and debris that can be found between Mars and Jupiter. In a different gravitational environment, this collection of rocks may have become its own planet. But in the region between Mars and Jupiter, planet formation was disrupted. The immense gravity of Jupiter prevented the material in the asteroid belt from coming together to form a planet. Instead, the leftover rock and metal remained as countless smaller fragments. So, with Ceres' promotion to a dwarf planet, what is the largest asteroid in our solar system? Right now, the title is held by Vesta, another asteroid belt rock with a diameter of around 300 miles. What about meteoroids? How do they differ from asteroids? Meteoroids are smaller than asteroids, so the difference is really as simple as their size. Generally, any rock small enough to mostly burn up in Earth's atmosphere is called a meteoroid, which means that a shooting star isn't a star at all, just a tiny rock. What a letdown, right? When these rocks are still in space, we call them meteoroids, but when the rock is burning up in the atmosphere, it's known as a meteor. And if any piece of the meteoroid is left after its trip through the atmosphere, the remnant is known as a meteorite. Pause the video here if you need to, and be sure that you have these definitions recorded. Unlike their rocky cousins, comets are made mostly of ice, dust, and frozen gases. These icy objects originate from the outermost regions of the solar system, the Kuiper Belt and the Oort cloud, far beyond the planets. Because they spend most of their time in deep space, comets are usually frozen and inactive. But when a comet's orbit brings it close to the sun, something dramatic happens. The heat from the sun causes the comet's icy surface to vaporize, releasing gas and dust. This forms the long, glowing tails that stretch across the sky and can be seen from Earth when the comet is nearby. Some comets can be seen in the sky for several weeks, depending on how close they are to Earth. Since comets are loosely held together mixtures of ice and rock, they can break apart over time into many smaller fragments that continue orbiting the sun. When Earth passes through this debris field, the tiny fragments burn up in our atmosphere, creating spectacular meteor showers, like the Perseids and Leonids. How is this different from the meteors we learned about earlier? It's not much different at all. Both are caused by small bits of space debris burning up in our atmosphere. But during a meteor shower, there are lots of small pieces of debris in our cosmic neighborhood, so you might see hundreds of meteors in a single night during these periods. Although asteroids mostly orbit in the asteroid belt and comets originate from the distant Oort cloud or Kuiper belt, their paths can sometimes change, bringing them into Earth's part of the solar system. Some of these objects become near-Earth objects, or NEOs, which astronomers closely monitor to track any potential collision risks with our planet. Throughout history, impacts from space debris have shaped planets and moons, including Earth. One of the most well-known impacts occurred around 66 million years ago, when a massive asteroid struck what is now the Yucatan Peninsula in Mexico. This impact, known as the Chicxulub event, caused massive wildfires, global cooling, and ultimately led to the extinction of the dinosaurs, as well as many other species. More recently, in 1908, a smaller object, likely a comet or asteroid fragment, exploded over Tunguska, Siberia, flattening 800 square miles of forest. While Earth has experienced destructive impacts, Jupiter provides an even more dramatic example. In 1994, comet Shoemaker-Levy 9, which had broken into multiple pieces, collided with Jupiter, leaving enormous dark scars in its atmosphere. This event showed the incredible power of cosmic collisions and served as a reminder of the potential impact threats that exist in our solar system. To protect Earth from potential collisions with space debris, scientists have developed strategies to track and even deflect hazardous objects. One of the most groundbreaking missions was NASA's DART, a test mission launched in 2021. This was the first ever attempt to change the course of an asteroid by crashing a spacecraft into it. In September 2022, DART successfully impacted Dimorphos, a small asteroid orbiting a larger one called Didymos. The collision successfully altered Dimorphos's orbit, proving that we have the capability to redirect potentially dangerous space rocks. While this mission was only a test, it was a major step forward in planetary defense, demonstrating that with enough warning time, humanity could prevent an asteroid impact that might threaten Earth in the future. Our solar system is filled with this debris, most of it harmlessly minding its own business far from Earth. While small pieces of debris that find their way to us can light up the sky and give us a star to wish on, larger pieces pose serious threats. Luckily, we are alive at a time when humanity has the ability to counter these threats. And with the ingenuity of coming generations like yours, that ability can be expected to grow. Who knows? Maybe you'll be the scientist who literally saves the world one day by finding or deflecting an Earth-bound asteroid. So, keep an eye on the sky until then and keep marveling at all its wonders. See you next time!